Hi everyone! In this video, we'll try to find the answer to the question, what are the 7 testing principles? We're going to check IS2QB theory and talk in human language after. Let's begin. Let's start with the IS2QB explanation. Currently, IS2QB is the leading global certification scheme in the field of software testing. And when we will talk formally, we'll use their syllabus and the glossary as references. A link to the IS2QB website will be provided in the materials for the video. According to the IS2QB, there are 7 principles that should be considered when developing the testing strategy for a software project or product. Knowing how to spot these principles and how to make advantage of them will make you a better tester. So, what are these principles? Testing shows the presence of defects, not their absence. Exhaustive testing is impossible. Early testing saves time and money. Defects cluster together. Beware of the pesticide paradox. Testing is context-dependent. Absence of errors is a fallacy. And that is basically it. This is the answer to the question. These are 7 testing principles. You can pause the video and read them one more time. We plan to have a separate video for each of the principles. So we are not going to explain the topic excessively here. We'll just provide a couple of sentences related to each of the principles. What says IS2QB, and where needed, we will translate this into the human language. Let's begin with principle number 1. Testing shows the presence of defects, not their absence. What IS2QB says about it? Testing can show that defects are present, but cannot prove that there are no defects. Testing reduces the probability of undiscovered defects remaining in the software, but even if no defects are found, testing is not a proof of correctness. I think it was more clear before the explanation. Let's translate this into the human language and move to the next one. A typical objective of testing is to find defects. It reduces the probability that end users will face bugs after release. If the tester has found 1,000 bugs, it means there are 1,000 fewer undetected bugs in the system, but it doesn't mean that there are no defects left in the system. The customer still can find the other 100 bugs. But the probability of that happening is reduced. As we said, there will be a separate video for each of this. Let's move on to the second principle. Principle number 2. Exhaustive testing is impossible. According to the IS2QB, it means testing everything, all combinations of inputs and preconditions, is not feasible except for trivial cases. Rather than attempting to test exhaustively, risk analysis, test techniques, and priorities should be used to focus test efforts. This principle is closely related to the previous principle. For any real-sized system, the number of possible test cases is either infinite or close to infinite. To run infinite number of test cases will require infinite amount of time. But we don't have infinite amount of time. In fact, we are very limited in time. So we must select a subset of test cases from it. There are different ways to do it, and we will discuss those in a separate video. Let's move on to the third principle instead. Principle 3. Early testing saves time and money. According to the IS2QB, it means to find defects early, both static and dynamic. Test activities should be started as early as possible in the software development lifecycle. Early testing is sometimes referred to as shift left. Testing early in the software development lifecycle helps reduce or eliminate costly changes. And it again looks like it was easier to understand before the explanation. Let's talk in human language. The cost of finding and removing a defect increases each time that defect escapes to a later life cycle phase. According to some studies, a defect found after release is at least 5 times more expensive to fix than a defect found during the requirements or design phase. That's why early testing saves time and money. Let's move on to the principle number 4. Defects cluster together. The ISTQB explanation says next. A small number of modules usually contains most of the defects discovered during pre-release testing, or is responsible for most of the operational failures. Predicted defect clusters and the actual observed defect clusters in test operation are an important input into a risk analysis used to focus the test effort. It sounds more complex than what it actually is. And in translation to human language, defects like to group, defects like parties. If you found a bug in one area, search for another one. You have an 80% chance to find one more in the same area, and only 20% of finding a defect in the next area, unless the next area is another defects cluster. The reasons for it we will discuss in a separate video. Let's go to principle number 5. Beware of the pesticide paradox. If the same tests are repeated over and over again, eventually these tests no longer find any new defects. To detect new defects, existing tests and test data may need changing, and new tests may need to be written. This particular explanation sounds pretty clear. A rare example is when the ISTQB language sounds like a human language. Let's move to the principle number 6. Testing is context-dependent. Testing is done differently in different contexts. For example, safety-critical industrial control software is tested differently from an e-commerce mobile app. As another example, testing in an agile project is done differently than testing in a sequential software development lifecycle project. And again, in the scope of this principle, there is nothing to add for now. ISTQB provides a perfect example of different contexts and testing. We will talk more about it in a separate video. Let's move on to the last principle. Principle number 7. Absence of errors is a fallacy. Some organizations expect that testers can run all possible tests and find all possible defects, but principles 2 and 1, respectively, tell us that this is impossible. Further, it is a fallacy to expect that just finding and fixing a large number of defects will ensure the success of the system. For example, thoroughly testing all specified requirements and fixing all defects found could still produce a system that is difficult to use, that does not fulfill the user's needs and expectations, or that is inferior compared to other competing systems. A lot of words and a lot of confusion. Let's try to say something about it in human language. Even if it would be possible to find and fix all the defects and build a defect-free system that perfectly conforms to its requirements, it won't ensure success. If the requirements were flawed, we now have a perfectly working wrong system. Checking the work product against a specification is part of testing. Another part of testing is evaluating a work product to determine whether it meets the user's needs and requirements. This is called verification and validation. That's all what we wanted to say related to the absence of errors is a fallacy principle. And it is the last principle on the list. In this video, we had a brief overview of 7 testing principles. It is just a small reminder for the people who are already familiar with the concept. And just need a couple of notes to recall the theory. We will learn each of the principles in a separate video. And that is our answer to the question, what is the difference between the 7 testing principles?